Today's lesson is on transforming parent functions. So we're looking at just the basic functions of a variety of functions, and then looking at how they kind of translate, how they shift and stretch and dilate, reflect, all of those things. So starting out is the constant function. This is like f of x equals just a constant. You might think of this also like y equals, let's just say the number 2. That is just a horizontal line at 2. Okay, identity function is y equals x. That's a linear function with slope 1 and y-intercept 0. Quadratic function, y equals x squared. So I've got 0, 0, 1 squared is 1, 2 squared is 4, and reflect that across. Cubic function, y equals x to the third. 0, 0, 1 cubed, 2 cubed. It's going to go off the graph a little bit. So all of these functions you've graphed before between algebra 1 and algebra 2. Square root function. So that's 0, 0. I can't plug in any negatives. Square root of 1 is 1. Square root of 4 is 2. And that's only going in one direction. Okay, reciprocal function, y equals 1 over x. That has a vertical asymptote at 0 and a horizontal asymptote at 0. And if you plug in, let's see, 1, we'll get 1. If we plug in 2, we'll get 1/2. If you plug in a half, you'll get 2. So this graph, and then on the other side, and then absolute value, y equals absolute value of x. If we plug in 0, we get 0. 1 is 1, and negative 1 is 1. Creates this v. So you should be familiar with all of those functions. This one, I'm going to assume you have not graphed before. The symbol for this, it looks like I've seen it written differently a couple times, but it's kind of like a bracket, essentially, with an extra line. Greatest integer function. This is, it's kind of like a rounding down function. So if you plug in 0, you're at 0. If you plug in 0.5, it's going to round down to 0. 0.9 rounds down to 0. And it doesn't jump up to 1 until you have exactly 1. And then same thing, 1.5, it's still at 1. 1.9, it's still at 1. And it doesn't jump up until 2. So what this graph looks like is this weird little step graph. So anything from 0 to 1 is 0. And then when you get to 1, it jumps up to 1. And anything between 1 and 2 just stays at 1, jumps up, and it repeats like this. And then backwards. So its greatest integer function, sometimes I'll refer to as like the step function, but that's what it looks like. So 8 functions that you kind of just need to memorize. If I give you an equation, you have to know what the graph looks like. Equation, graph. Okay, so now taking the parent functions and translating them. So vertical translation just means we are shifting the graph up or down. Horizontal translation, we're shifting it left or right. So a vertical translation is when you take your function and you add or subtract something at the end. Horizontal translation is we're like shifting the x left or right. So I'm just going to show you how this can be applied to some of those parent functions. So like y equals x squared plus 3. That would be a shift up 3. Y equals x to the third minus 4. We would shift the graph down 4. Y equals square root of x plus 2 is shifting the graph up 2. So you can kind of just see the general pattern. Horizontal, this would look like, maybe if we're doing a quadratic, it would be y equals, in parentheses, x minus 3 squared. Now, inside the parentheses, it's opposite of what we would think. Minus 3, we think left, it's actually a shift right 3. Y equals, so square root inside the square root, this is outside of the square root, so inside the square root, if I have x plus 2, that would actually shift left 2. The reciprocal function, 1 over x minus 1, that shifts the vertical asymptote right 1. Okay, so let's actually graph one of these. Let's do the reciprocal function, y equals 1 over x minus 3. First, I'm going to graph the parent function, just y equals 1 over x. So that has vertical asymptote at 0, horizontal asymptote at 0. And I'm just going to do a quick sketch. So the key things I'm putting on here are the asymptotes, and then I kind of do this main point here and here, and continue my lines. Okay, so now that was the parent function. Now I'm going to do a shift down 3. Down 3. So what that's going to do is shift my 1, 2, 3 horizontal asymptote down 3, and then all of my points down 3. My vertical asymptote stays the same. So this point is shifted down 1, 2, 3. This point also shifted down 1, 2, 3. So I just graphed my parent function and then did a vertical shift down 3. And I have this graph. Okay, so now for a horizontal shift, let's do y equals the absolute value of x plus 3. If you graph the parent function, absolute value, that's the v. It starts at 0, 0, and then has the slope 1 over 1. This is just a shift left 3. So take your center point and move it left 3, but the slope stays the same, up 1 over 1. Okay, now looking at reflections. Reflection across the x-axis is when you have a negative in front of your function. Reflection across the y-axis, we're applying a negative, but it's like we're applying it inside the function. So we're applying it on the x. Okay, so let's go straight into an example. Let's do a quadratic. Y equals a negative out in front, and I'm also going to do a shift, x minus 2 squared plus 3. So I like to start with the parent function, 0, 0, 1, 1, 2, 4, and reflect those over. So that is the parent function, y equals x squared. Okay, so I need to shift right 2, and I need to shift up 3, and then I need to reflect in the x-axis. So let's think about this. I like to think about that center point, go right 2, up 3. Here's my center point, and then now it is a reflection, so it's going to open down. So find those key points, opening down. All All right, so there we have shifted and reflected the quadratic parent function. All right, now let's do a reflection across the y-axis. So let's do y equals, instead of a negative out in front, it's a negative kind of within, negative x, and then a plus 2 on the outside. So this plus 2 will shift up to, actually let me back up a little bit. We're going to graph the parent function. Square root of x is 0, 0, 1, 1, 4, 2. And then I'm going to shift up 2 and then reflect across the y-axis. So if my starting point is here, I'm going to go up 2, and instead of to the right, it's going to open to the left. It's kind of this reflection. So I need to go that left 1, up 1, and then left 4. 1, 2, 3, 4, up 2. So it's going to go in this direction. Okay, so now we're going to look at dilation. That is multiplying by our function or by our x value. So a vertical dilation is when we have a value that we're multiplying by the function. And a horizontal dilation, this would be within the function f of a times x. Okay, so example here. Let's do that greatest integer function. We're going to do 3 times x plus 2. Okay, let's quickly graph that parent function. So this is when we had closed circle, go to the right, open circle. Closed circle, go to the right, open circle. And it kind of takes a while to graph this one. Okay, get the point here. Let's do one more. Okay, so I like to think of that first one that I do at the origin. And this is a shift left 2. And then notice how these are all kind of a slope up 1 over 1 to get to the next one. That is going to change to a slope up 3 over 1. All right, so I'm going to shift that starting one is left 2 from the first one. And then from that closed dot, I need to go up 1, 2, 3, right 1. And then the line stays the same length. So same thing, up 1, 2, 3, right 1. And then to go the other way. All right, so I've changed the dilation. In a way, it's like it's changing the slope. It's stretching it or compressing it, depending on what number you have. Okay, now this one, let's do square roots. So let's do y equals the square root of 4 times x. Okay, parent function 0, 0, 1, 1, 4, 2. So let's plug in what happens when you plug in 0. 4 times 0 is 0, so we still have that. If you plug in 1, 4 times 1 is 4, and the square root of 4 is 2. And then let's plug in 4. 4 times 4 is 16, and the square root of 16 is 4. So it looks just like the square root function, but it's being stretched. Okay, on your notes, we have these absolute value transformations. We're going to save these for in class. So you have everything you need for this video and for the lesson. Good luck.